So, hello everyone again, this is lecture 1 part 2 of dual nature of radiation and matter. In this lecture, we will continue our further discussions after the introduction part. So, in the previous lecture in the previous part, the introduction is completed. Let us move on to the second point, that is electron emission. So, I am Samir Lavankar. Let us begin our discussion. So, course outline for right now only introduction is being completed. Let us just go on with electron emission only. I won't try to explain the further things right now. Let us go on to electron emission and let us understand the basic crux of this complete chapter. Okay. So, electron emission. So, we know that metals have free electrons that are responsible for the conductivity, quite evident everything, because in major of the chapters also it was being assumed first of all that anything which is being moving from point A to point B will be electrons only, and generally positive charges are being static. Hence, the major part which is being used for your conductivity is called is negatively charged particles only, and hence they are called as electrons. Okay. Please remember, it is called as free electrons, as the name says, free as in they are very easy to move or they are free to move. Okay. So, we know that metals have free electrons, that is negatively charged particles that are responsible for their conductivity. However, the free electrons cannot normally escape out of the metal surface, quite evident, very easy, because why will they escape? Because when these, let us say this is so they are very closely packed, they are closely packed, and hence they cannot shift from its positions. However, the free electrons cannot normally escape out of the metal surface. If an electron attempts to come out of the metal, so what happens, what actually happens, why was there a reason as in why it cannot come out? So, if an electron attempts to come out of the metal surface acquires a positive charge and pulls the electron back to the metal. Fine. So, let us suppose this is that metal surface being explained here. Let us suppose this is that electron. Okay, so let me just make everything much more clearer. Let us suppose I am using black color for the electrons. Let us say this is that electron which was going out. Okay, so when it was trying to go out, in that very time frame, in that very specific time frame, what happened was there were a bunch of positive charges being accumulated here. Maybe they came from this directions and so on. Due to that, what happened was this process of going away led to the attracting forces, and hence this negative charge were being intact on the metal surface only. Okay. So, if an electron attempts to come out of the metal surface acquires a positive charge and pulls the electron back to the metal. Okay. The free electron is thus held inside the metal surface by the attractive force of the ions, quite evident, because as positive and negative charges attract each other. Therefore, this free electron is thus held inside the metal surface by the attractive forces of the ions. Okay. Consequently, the electron can come out of the metal surface only if it has got sufficient energy to overcome the attractive pull. Now, what does it try to say? It is very important point, because let us suppose. So, basically what is happening is, you may have heard this concept, you may have studied this concept in the concept of electric charges and potential also, that when there is a quantitative value of the attractive forces between two particles, two charged particles, right. So, if let us suppose, let me take a condition that let us suppose this is a negatively charged particle and this is a positively charged particle, fine. Let us suppose this is that group of positively charged particles. Now, if the attractive forces, let me write the attractive force like this, is denoted by F1, and the repelling forces as in, why will there be a repelling force? Because it has a very higher energy and it tries to go out. So, in the concept of atomic structure also, you may have heard that when the energy is being imparted into the electron, it tries to move in the above orbit as in which is having a higher energy state. So, it tries to go to the higher energy state if the energy is being inserted inside, right. So, let us suppose that energy is being inserted inside, and this has an electron energy such that when it converted to force has a repelling force F2. There will be a repelling force only, because why else it would try to go out? If it would have been an attractive force, then it would have stayed in the metal surface only. It was a repelling force, that is why it was going away from the metallic surface, it was going to emit from the metallic surface, right. So, if this F2 is greater than F1, then in no sequence it will get selected, it will get attached to the metallic surface. If F2 is less than F1, then this first case would have occurred, that is, the electron is thus what we can say, being a positive charge pulls the electron back to the metal surface. Okay, so this was a simple point which I need to convey. So consequently, the electron can come out of the metal surface. Why? Only and only when it can come out, if it has got sufficient energy to overcome the attractive pull. So if it has got sufficient energy to overcome the attractive pull, as in this pull, if it has such power so that it can overcome this pull and can go away. Okay. So a certain minimum amount of energy is required to be given to an electron to pull it out from the surface of the metal. Fine. So what is the sufficient minimum amount of energy we will get to know in subsequent slides, subsequent lectures. For now, let us denote by sufficient amount, some certain minimum amount of energy only. So a certain minimum amount of energy is required to be given to an electron to pull it out of the surface of the metal. This minimum energy required by an electron to escape from the metal surface is called the work function of the metal. Okay, so a new term for you, please remember, because in exams also sometimes work function is given in the question. So this minimum energy required by the electron, so this is what? This is minimum energy. So this minimum energy required by an electron to escape from the metal surface is called the work function of the metal. It is generally denoted by phi naught and is measured in electron volts. Okay. So if you have studied the concepts or chapters of atomic structure or nuclei also, then you may have heard that the charges on the particles or the energy of the electrons in any of the orbits are being measured generally in electron volts only, right. So that is why this is also measured in electron volts. So amount of charge or minimum energy required by the electron to escape that metal surface, to escape from the metal surface is called as work function of the metal. It is generally denoted by phi naught, please remember, it is generally denoted by phi naught and is measured in electron volts. Fine, okay. Then let us move on next line. So as you can see in this table below, so some of the work functions of certain metals are given here. As you can see, it is cesium, potassium, sodium, calcium, I guess molybdenum, then lead, aluminium, mercury, copper, silver, nickel, platinum. So generally some of the metals which are being used to calculate or which are being used to emit the electrons are being explained in this table. Okay. So now what as the name says, what is electron volt? So basically what is 1 electron volt? So 1 electron volt is the energy gained by an electron when it has been accelerated by a potential difference of 1 volts. Fine. So majorly the concept will be explained in the subsequent chemistry lectures also or in nuclear atomic structure also. Here I will not go into detail of that stuff. So 1 electron volt is the energy gained by an electron when it has been accelerated by a potential difference of 1 volt. So that 1 eV electron volt is equal to 1.602 into 10 to the power minus 19 joules. Fine. So please remember, so till now whatever thing you need to remember, one you need to remember E by M, one you need to remember E, and here as we know that only E is measured in coulombs, EV is measured in joules, but the value is same, right, that is 1.602 into 10 to the power minus 19 coulombs here, joules here. Okay. This unit of energy is commonly used in atomic and nuclear physics. Okay. The work function phi naught depends on the properties of the metal and nature of its surface. As you can see, it depends upon the properties of the metal. So property, as different metals have different properties, hence the value of work function also changes. So the work function phi naught depends on the properties of the metal and the nature of its surface. Okay. The values of work function of some metals are given in its table. As you can see, this is the table explained here. These values are approximately as they are very sensitive to surface impurities. There will be some tolerance for each of these. Okay. So these values are approximate as they are very sensitive to surface impurities. So if some one of the major application, one of the major advantages of the surface impurities will be explained to you in the chapter of semiconductor devices. What are these impurities? Why are these impurities added? What is the reason? Why is there a change in the properties of the semiconductors when the impurities are being added? Will be explained or will be dealt in the semiconductor devices chapter. For now, we can understand that if this surface impurities are being dealt with, then there is a change in the work function of the metals. Okay. So, okay. Next is note from the table that the work function of platinum is highest, phi naught is equal to 5.65 electron volts, but it is lowest for cesium. As you can see, it is lowest for cesium. Okay. So as you can see, the value of electron volts, the value of work function is increasing. Let us move on. Okay, so this is the final concluding part of electron emission. So why the minimum energy required for the electron emission for the metal surface can be supplied to the free electrons by any of the following physical processes. Okay. So, before explaining these three processes, what is the basic agenda, what is the basic requirement, why we are trying to do this is, let us suppose this is one of the electron, right. Now, this is called as free electron. Right. Now, what is our purpose? By some way or the another, we need to, let us suppose this is on the metal surface. Now, we are trying to remove it from this metal surface, so that it can move, or it can move, let us suppose if it is in a discharge tube, it can go and supply current, etc. Basic final result we want is that we need to get the free electron out of this metal. What are the ways in which we try to impart energy, or we try to do some things so that this electron gets removed out from the metal, is the complete process which are being done by these three things. First is thermoionic emissions, second is field emission, and third is photoelectric emission. This photoelectric emission is one of the major part of this complete chapter. Okay. So, this is the agenda which I explained. Let us move on to these three physical processes now. Okay. So, the first is your thermionic emission. So, by suitably heating, as in the previous slides also we understood that in some of the ways these electrons are also being emitted when there was a change in the temperature of the metal. So, that corresponds to your thermionic emissions. When the ultraviolet light is being emitted on the metal and the electrons are being emitted, then those are called as photoelectric emission, and similarly fields emission. So, these are the three different ways in which finally what is the agenda, these free electrons should be out of the metal. Okay. So, thermionic emissions, by suitably heating, sufficient thermal energy can be imparted to the free electrons to enable them to come out of the metal. Fine. So, please remember, always there is sufficient thermal energy required. It will not happen that you increase the temperature by 1 degree Celsius and some sort of energy, 0.1 joule of energy is being released, or 0.1 energy is being imparted, and there will be a release of the electron. There will be some threshold energy, there will be some threshold frequency, there will be some threshold value of potential such that the electron is being emitted. Fine. So, that is the only concern why sufficient is written here. So, by suitably heating, sufficient thermal energy can be imparted to the free electrons to enable them. Please remember, these energies being imparted where? It is imparted to the free electrons. Okay. So, by suitably heating, sufficient thermal energy can be imparted to the free electrons to enable them to come out of the metal. Fine. So, this is called as thermionic emissions. The second is your field emissions. What are field emissions? By applying a very strong electric field of the order of 10 to the power 8 volt per meter to a metal, electrons can be pulled out of the metal as in a spark plug. So, one of the example of field emission is given as, which is spark plug. So, in which basic agenda, you just apply the electric field. To the electric field, there will be an attraction between the positive and the negative charge particles, and the attraction from the other side of that positive particle will be such that the positive charges which are being evolved in the same metal does not have such kind of energy, and hence the electrons are being pushed apart from the metal surface. Okay. Third is photoelectric emission. So, when light of suitable frequency illuminates a metal surface, electrons are emitted from the metal surface. Basic concept which we will get to know in photoelectric effect also. These photo light generated electrons are called as photoelectrons. Okay. So, that is the complete concept of electron emission. So, basically what I need to explain, let me just go on. So, basically what we did was we got to know about that electrons need to come out only and only when you got sufficient amount of energy to overcome this attractive pull. Fine. Why was there a need to take out this electron? One is for the emission or the complete circuit, for the electric circuit to complete. This complete agenda, this complete application will be dealt in subsequent slides. You can just wait for some few lectures. Okay. Then we got to know about work function. Please remember the definition of work function. What is work function? The minimum energy required by an electron to escape from the metal surface is called as the work function of the metal. It is denoted by phi naught, and it is measured in electron volts. Fine. Okay. So, much more. Then we got to know about different metals, cesium, potassium, sodium, etc. We got to know that platinum has a very high work function, and cesium has a very low work function. Also, we got to know about electron volt. So, definition of electron volt was explained. Maybe this can also be asked in the question that define electron volt. So, please remember this also. So, what is 1 electron volt? So, 1 electron volt is the energy gained by an electron when it has been accelerated by a potential difference of 1 volt. And please remember, 1 electron volt is equal to 1.602 × 10⁻⁻19 joules. Please remember, it is not coulombs, because many people make a mistake here. It is not coulombs, it is joules here. Okay. Fine, then, so these all things are being explained, and finally we got to know that the minimum energy can be explained in 3 different ways. Okay. So first way is basically that you try to use heating. So basically heating, which leads to increase in temperature basically, right. Second is that apply an electric effect, so, applying an electric field, and third is that you use a suitable frequency illuminated light from a source being imparted onto the metal surface, right. So due to these 3 phenomena, so first is basically called as thermionic emission, second is called as field emission, third is called as photoelectric emission. Fine. So that is the end of electron emission only, I guess. Okay. So in the next part, let me stop it here only. In the next part we will start a photoelectric effect. Now this is the major concept, which I need to go in very detailing, because we will get to know what photoelectric effect, what is this photoelectric effect, what are the different factors being devised in the photoelectric effect, and so on. Okay. So let me stop it here only then. So thank you so much.